So good evening, everyone. So here we go again. This is our another review video on in preparation for our summative number 4 for tomorrow. And in this video, I'm going to present to you 3 examples just like or similar to what I have given in the classroom earlier. And this will make use of the concepts, of course, of the primary, secondary parts of a triangle, including the theorems that we've discussed earlier. So we talked about the relationship of the angles in a triangle, which should always add up to 180 degrees. We also mentioned about the exterior angle of a triangle and how it's related to its interior angle pair, and also to the remote interior angles of the triangle in relation to a certain exterior angle. And so we know already that an exterior angle in relation to the remote interior angle pair, they are linear pairs. And the sum of the remote interior angles in relation to an exterior angle will always add up to that exterior angle. So we have here one example. So let me just make this bigger a little bit. And here we are to solve 7 angles. And we can see roughly around 3 smaller triangles that could help us solve all the angles here. So let's begin. Let's take it. Let's take the angle from 1 until 7. Let's see if we can do it. So here we have 1 here. So 1 is over here, and we see that there is what we call an exterior angle. Okay, and in the exterior angle measures 110 degrees, and so we learned earlier that an exterior angle will equal to 180 together with its remote interior angle pair. So 180 minus 110, therefore angle 1 is equal to 70 degrees. Alright? And if we focus alone on this triangle, it has already 2 angles, which is 63 and 70 degrees. And so we simply add these 2 angles here. 63 and 70 is 3 and 13. Which means to say 63 and 70 is already equal to 133. And since we know, based from the definition of a triangle, that all the angles here will equal to 180, therefore we simply subtract 133 to 180 degrees. And what do we have? So this will be a 7, and this will be 4. Therefore, angle 2 is 47 degrees. So we're done already with the first 2 angles. Let's move to the third angle of our given. So here you can see angle 3 actually forms another relationship with the exterior angle 110. And we mentioned earlier that for one interior angle, there exists 2 exterior angles to it. So here you can also say that angle 3 is linear pair with 110. So this would be also 70 degrees. Or another reason for that is because angle 1 and angle 3 are also vertical angles. So they are just equal. Now over to this side here, we can see that there's a 45-degree angle. So if we want to solve angle 4, we can make use of this angle. And angle 4 and 45 degrees are just vertical. Therefore, this is 45 degrees as well. And for us to solve angle 5, we simply have to add 70 and 45. That becomes 115. And you know the drill, we subtract it to 180 degrees. So this will be 5, this will be 6. So this is 65 degrees. We're almost done. We are already in angle 6. And still, we can make use of a lot of reasons for angle 6. But, of course, we can say that angle 6 and 45 degrees here are linear pairs. Also, angle 6 and angle 4 are linear pairs. So, therefore, we simply subtract it to 180 degrees. So, 180 minus 45 will give us, okay, 5. This will give us 3. So that's 135 degrees. So for this one, 135 degrees. How do you get angle 7? Still the same process. So 135 to be added to 28 degrees would be 13, 1. So this is 163. So that means 180 minus 163 becomes 17 degrees. But wait, there's another process in getting angle 7. We know the definition that says the sum of the remote interior angles is equal to the exterior angle. So take note that 28 in angle 7 are actually the remote interior angles of 45 degrees. And therefore, it should add up to that. So in this case, if you don't want to have a double step process of adding this one and then subtracting, you can simply go back to the definition or to that theorem that proves that these two angles here will simply equal to the exterior angle here. Okay? Although we can always make use of all these other definitions, but the way we were taught about these other theorems is for our lives to get better, to get easier when we're solving this kind of things, especially if you have this one. So in number 2, we have here a triangle, and we can see that there is an exterior angle, which is 9x minus 14. We can also see that there are two angles, and these two angles could be or are the remote interior angle, of the exterior angle. And we know that the sum of the two will equal to the exterior angle. So we simply say 4x plus 2 plus 3x plus 14 equals to the exterior angle 9x minus 14. So doing the algebra, we have 7x here plus 16 equals 9x minus 14. And if we do the properties of equality, we can transfer 7x to this side, which becomes 9x minus 7x, and negative 14 to the other side. So that becomes positive 14. 30 equals 2x, and x equals 15. But this is not the answer. Our angles are 4x plus 2 degrees. So therefore, we substitute for x plus 2 is 4 times 15 plus 2. That is 62 degrees. So this is our angle here, 62 degrees. What about 3x plus 14? That would be equal to 3 times 15 plus 14 would be 45 plus 14, and you have 59 degrees. So this is 59 right here. Now, even if we don't solve for this anymore, we know already the measure, because as we've said, we simply add the two angles here. So that would mean 1 and 12. So 121 degrees. But just to be sure, let us double check. So 9 times 15 minus 14. So here 9 times 15, you have a 5, carry 4, and that becomes 135 minus 14. And indeed, it's equal to 121 degrees. And so we have all the values that we're looking for. And that is again through the use of the exterior angle and its relation to the remote interior angles of the triangle. Let's go to another example. This time, you're not anymore given with the illustration, but just the narrative. So it says here, in triangle LUV, the measure of angle U is 10 less than the measure of angle L. And measure of angle V is equal to the sum of the measures of angle L and angle U. Find the measure of each angle. So first, we try to digest. There are only 3 angles involved. And we always start with the angle that should take X. So which angle do you think will take X? So here, angle U is less than the measure of L. And so angle L is being compared to angle U. Angle U is being described as 10 less than the measure of L. Angle V is equal to the sum of the measures of angle L and angle U. So, how do you find now the measures of the two? So, in terms of its equation, or in terms of the representation, we represent X to be your angle L. Because if you take note of the first or the preliminary sentence here, angle U is 10 less than that. So if you try, let's see if we can reverse this. Measure of angle U is the X. And the measure, wait, it's supposed to be angle L. I'm sorry. Angle L is the X. And the measure of angle U is 10 less than the measure of angle L, which means to say it's going to be X minus 10. Now, angle V is just equal to the sum of the measures of angle L and angle U. So therefore, measure of angle V is equal to X plus X minus 10. Alright? So we're now done with the representation, and we know very well that for us to find the equation, all you have to do is add everything. So you have equation here. Angle L is X plus angle U, X minus 10, plus angle V, X plus X minus 10, which is, of course, equal to 180 degrees based from the definition of a triangle that says all angles should add up to 180 degrees. So here in my equation, I can combine all the x's. First, I have to remove the grouping symbol, so I can just remove it from here. Anyway, it won't matter anymore because the operation before is simply addition. So here I have 4x's minus 20 equals 180. And here, to simplify, 4x becomes 200. And x is equal to, okay, 50. But that is not yet the answer. Let's go back to our given. So this becomes 50 here. This becomes 40. And this becomes 90. Let's see if the logic holds. X is 50. This is 10 less than X, so that's 40. And angle V is just the sum of angle L and angle U, which is actually correct. So here, we've proven that our answers are correct. and which means to say we have arrived to the correct answer. So this comes with a formative assessment that I will also upload in your LMS. And take note, answer them, watch the video to help and guide you with the answer, and send me your answer so that I can also see and I can correct you from there. Or if you have any other questions, kindly communicate with me in through our LMS so that I will know and I could also answer you. So good luck to our summative number 4 tomorrow. Thank you and goodbye.